Of particular interest to us when we're analyzing equations and thinking about their graphs are the locations where a graph crosses through the axes. So whether that's the x-axis, we call that the x-intercept, or the y-axis, we call that the y-intercept. And so when we're talking about the x-intercept, if we draw ourselves a coordinate plane here, if we're on the x-axis somewhere, well, that means we haven't moved up or down, although we have moved left and right. And so that means that our y-coordinate, without any vertical movement, is going to be 0. And then by a similar approach, if we're on the y-axis, that means we've had no left or right movement. So that means that our x-coordinate is going to be 0. And so to find any intercepts that a function might have, we can just plug in 0 for y and solve for x. And then we can plug in 0 for x and solve for y, and that'll give us those locations that are of interest to us. So if we take a look at the first one, we'll start off with the x-intercepts of this one. So I'm going to set y equal to 0. So I've got 0 equals x cubed minus 4x. So for this, I'm going to have to solve by factoring. We're going to look in greater detail at these types of equations to solve, but hopefully we know that we've got to factor out an x like we did in the previous chapter, so we're left with x squared minus 4. Then we have to keep on factoring, so x times, hopefully we recognize that as a difference of squares, x plus 2 times x minus 2, and then to solve an equation like this, we're going to set each of these factors equal to 0. So we're going to have x equals 0, we're going to have x plus 2 equals 0, and then x minus 2 is going to equal 0. And then if we solve each of those mini equations, we get our, in this case, 3 places that this graph crosses through the x-axis. We've got 0, we've got negative 2, since we subtract 2 from both sides here, and then if we add 2 to both sides in this case, we'll end up with positive 2. So we've got 3 places that our graph is going to cross through the x-axis. For the y-intercept, usually this is a little bit easier because we don't have the possibility of having multiple y-intercepts if we're talking about a function. So if it's a y equals equation, it's going to be pretty simple. Just plug in 0 for x everywhere. Y equals 0 cubed is 0, minus 4 times 0 is 0, so we're just going to get y equals 0. So then if we wanted to plot out the entire graph here, we could use these points to kind of help inform us. But for right now, we can go ahead and stop there. For this next one, if we want to find the x-intercept, well, we're going to set, again, y equal to 0. So this time it's y squared, so we get 0 equals x plus 4. So this is going to be the easier of the two to solve for. We're just going to subtract 4 from both sides, and then we get x equals negative 4. So this graph just has the one x-intercept. The graph is going to cross through negative 4 on the x-axis. For the y-intercepts, we're going to plug in 0 in place of x. So again, that's not going to be too bad here. We're going to have y squared equals 4. Now to solve, there's one of 2 ways that we can approach it. One would be to factor, so we could set this equation equal to 0 by subtracting 4 from both sides. And then we get y plus 2 times y minus 2. And then we can take, just like we did on the previous question, each of these factors, set them equal to 0, and then solve these mini equations to find the 2 y-intercepts. So hopefully we can see that we're going to get negative 2 and positive 2. Or if we wanted to, we could, in a shorthand format, write it y equals plus or minus 2. I'm generally a lazy person, so if I can take an easy way out on something, I'll do it. The other way we could have approached this, and I'll move over here for this, is if we left it at y squared equals 4, we could have taken the square root of both sides. Now, in the previous video, I had said that we were not going to include the plus or minus when we take the square root. The exception to that is when we have a circumstance where we're taking the square root of both sides of an equation, like we are in this circumstance. If if I take the square root of both sides of an equation, then in front of one of the two sides, I need to include a plus or minus. Because when we're solving an equation, we're trying to find all of the solutions to that equation, not just one of them. And so, unlike the previous circumstance where we had y equals the square root of x plus 6, and so in that case we just had this square root in the equation, and so we were just assuming to just take the positive square root, the principal root. In this circumstance, because we're solving an equation here, we're going to have to put the plus or minus in front of the square root of 4, which is 2. And that should, whoops, lost ourselves here. That should make sense to us, because no matter what technique we use to solve, we should be getting the same answer. And so I solved by this factoring approach first for us to see that y equals plus or minus 2. We have two y-intercepts in this case. So when we solve using this square roots technique, we should get the same thing. We shouldn't get different answers depending on what method we use to solve. So something to stick away in the memory bank. We'll certainly come across this plenty of times in our future.